Hello, nginibingelele nginamukele futhi namhlanje ehlelweni YouTube and Facebook lessons broadcast. I am Mr. JF Chavangwane. I'm here to help you with your mathematics grade 11 and 12. All right. Already, okay. In the previous video, we introduced the basics of circle geometry. Now that we have done the basics, the definitions of what is a radius, what is a diameter, what is a secant, what is a chord. If you're still not sure about that, make sure you go back and watch the previous video. For now, okay, in this lesson, our main focus will be only the center circumference theorem. I call it the center circumference theorem because it's relating the center to our circumference. So now, with the proofs, with your grade 11 and grade 12 papers, they can give you any proofs of the theorems and they require you to prove them. Okay. So now, as I have dedicated this lesson to the center circumference theorem, which I like it to call it that way. Now, we are given a question here. We are saying, given a circle with a center O, importantly, there is a center. Please be careful. Not all the theorem requires the center, but with this one, you have your center. Our circle is having the center. Now, they are saying the center O. Prove that AOB is equal to 2AC. Let's say our A and our C and B. Now the theorem is saying prove that angle AOB. Which angle? You remember the center circumference theorem. So the angle at the center, we are focusing on this angle here, right? And then circumference, you see I'm calling it center circumference theorem. So center is here. Where's the circumference? There. So you prove that this angle is equal to 2 times angle 2ACB. So we have 2ACB. So this angle is the one that they are looking for. So we are saying that angle at the center is twice angle at the circumference. That's what you are told, right? So, but before we go to proof, we have to make sure you remember your grade 10 maths, because maths is constructive. We will build on what you already studied, right? Let's open a space and then make sure we have enough space. So you need sub-knowledge. I will call it sub-knowledge because we need the small knowledge. You build with a small one to a big one. So now you will see these things. You've done them in grade 10, right? So now if we have a triangle, importantly that you know your triangles, right? Now if you have a triangle with 2 adjacent sides that are equal, right? By adjacent sides, I'm saying sides that are from the same point. Let's say this point, maybe it was O, A, B, and we say we have line AB equals to, OB, we wanted to say OB, not A, so pardon me for that. This is O. Alright, so if we are saying that line OB, according to the diagram, we are saying if you have this line, 2 adjacent lines that are equal, then what is the implication of that? This implies, you see the sign means implies that the base angles are equal. Which angles are base angles? The angles that are opposite to your point where your lines are coming from. So this angle, we are saying is equal to that one, right? They are equal. Then that implies angle A is equal to angle B. The reason for this one, it's angles opposite equal sides. right? One of the reasons you can say is to say base angles of an isosceles triangle, because this is an isosceles triangle. So isosceles triangle is a triangle which has two equal sides or two equal angles. If you have two equal angles, that says the two opposite lines are equal. So now that is the first theorem that you must know. What else? Another one, triangle theorem, that will assist us to solve, right? If you have a triangle, now you have an angle here. Let's say this is x, maybe this is y and z, right? Then if you have the exterior angle, the outside angle of your triangle, angle x is equal to y plus z. This they represent your opposite interior. The exterior angle of a triangle, the exterior angle of a triangle is equal to the sum of the two opposite interior, right? The interior angles are 1, 2, 3, but those ones we are focusing on are this opposite interior angle. So this we call the reason exterior angle of a triangle. So this is the information that you require for you to solve the problem, right? So now another theorem that is not a theorem actually, is the information that you must know. If you have a circle, right, and you have a circle, from your circle you draw lines from the center to circumference. If this, you draw a line, this line, and you draw another line, you choose to draw all the lines from your center exactly to your circumference, and you draw all your favorite lines. All these lines, they are equal because they are all your radiuses. All your radiuses, and a plural of radiuses, you call that radii, right? So if you have more than one radius, you call them radii. So that's all for you to know before we attend to the proof. So this information is information that you should have studied in previous grade, but nonetheless we just revised. Now you know if you have not studied. Okay, so where do you start? You start by constructing a line when you are asked to prove this theorem. So where do we start? You construct a line. You see the word construct, that means you draw your own line that is not part of our drawing. Let's construct. Construction, you represent it in dotted lines, so that we tell the examiner to say, no, examine, this is not part of your question, but I have decided to construct. To construct, even if you don't know what to write, you already have your mark already there, even if you don't know what else to do. All right, just by doing the construction right, you have 1 mark out of 5 or 6. So it's very important to make sure you don't lose marks, you don't skip questions, you make sure. Then after construction, you see that the angle there now is divided into 2, so we can call this O1 and this O2, and this C1 and C2, but I think we have to use different colors so that we see properly. So I think a blue color will do. And then we divide this into O1 and O2. O1 and O2. Right. Then let us look now. Let us look, how do we solve? Now we choose, you look at your diagram. Now you have constructed, you see now you have constructed triangles, right? You have this triangle, right, and that other triangle. So I'll choose to extract one. It's not necessary, this is not part of what you have to do, but I'll just do it because I want to make sure you see what I'm doing. So I'll choose the other side of a triangle with right, properly, no, I think, okay, from there, let me the color that I used in the drawing so that you don't get confused. So let's draw our line. Alright, I'll draw that line. Now, okay. Alright, now you have the line. No, the line is in broken, so it's a broken line, that one in brown. So you have that line which is in brown, and then you have your black line. We extract. To extract, that means you take out from the drawing. It's not necessary, but I'm doing this so that you understand what I will be doing next after this, right? So after extracting, now you have your A, that is here, your O, and you have your C. There you have O1, and then you have C1 there. Okay, so now you see I've extracted part of our triangle, this one, right? The triangles that I see. But from our drawing now, you see, let's use our theorems. Remember, I said if you have radiuses or radii, if you draw them from the center, it doesn't matter from center to circumference, whether you draw from here to there, as long as it's from the center to circumference, all those lines would be equal. So from this one we see that line is equal to that one, because they are both radii, and this one is equal to all this line, OB, OC, OA, and OC. All those lines are equal, but our drawing now it looks untidy. Let's not make our drawing untidy, but it's to show. So from there we see that this line we said is equal to that one. So write down. So this part of extraction does not have marks. You don't have to do it, but you have to do what? To say line OC, right? Line OC is equal to which line? OA. Write down. Don't say you know. You can see OC is equal to OA. You have to write this one down because it has marks. And then whatever you are writing with Euclidean geometry, especially circle geometry, you have to give reasons. Why are we saying these lines are equal? Remember, I said they are both radius, so they are radii, right? So what else? So that's your mark. Then next, so if you see that you have two lines that are equal, remember, now we go back here, you have two lines from point O, they are equal. That means the base angles of those lines, they are equal. So you have two lines here, you have two lines, this line and that line, they are equal. They are from point O. So what is the meaning of that? The base angle. Which base angles are equal? We are saying the base angle is C1. Angle C1 is equal to angle A, right? What is the reason? The reason angles opposite equal sides, right? So if you have angles that are opposite equal side, then they are equal. If you have two sides, this side is equal to that one, that means the base angle C1 and A, ziyalingana, they are equal, right? Then what else? So from that theorem of isosceles triangle, we have extracted, and that is a mark. What else do you need now? The last theorem, remember I told you, the last one, this one. You need to say what? This exterior angle, O1, guess. O1 is equal to what? Tell me. Alright? O1 is an exterior angle of a triangle. Exterior angle is the angle that is outside. Angle engaphandle is an exterior angle. So, angle engaphandle, or the exterior angle of a triangle, is equal to the sum of the two opposite interior, right? So these are interior angles of that triangle C1A and this one. All those angles are interior angle, but we want the sum of the two opposite. So this one and that one, they are equal. O1 is equal to angle A plus angle C1. You write the cap to say those are angle, right? Why did we say so? Because they are exterior angle of a triangle. Then what else? Now you go to equations to see, okay, we related ACB, right? ACB, but the main angle of purpose here is angle C, right? So we want to relate the center O with that angle C. So now that means this A, we have to remove it because it's not related to the center and the circumference that we want to relate. So how do we remove that one? A, we said A is equal to what? Is equal to C1. So in the place of A, you can write C1, right? Plus C1. So this is equal to 2C1. Then now, what else? We can erase here so that we open space. We want to erase this section. Same thing, you do the same thing with the other side. So now, if we go on the other side of a triangle, right? You want to find your O2, but you don't just go and find O2. You start with the same process. You can extract the other triangle if you want, but then I won't extract because I've extracted the first one. So it's the same one with the other one. So now, okay, now from there, from this triangle, you say, you write in triangle what? Which triangle are you focusing on? BOC now. We are focusing on triangle BOC. In fact, we forgot to say in triangle what? AOC, to make sure we differentiate, but I've extracted. So now we focus on the other triangle, in the other triangle BOC. So this is the triangle that we are talking about, right? This triangle. In that triangle, what is happening with the triangle? We see that the line OB, the same thing, the line OB, ilingana na lipi line in that triangle, obvious, you know, that is OC, very brilliant. And why are we saying those lines are equal? Because they are both radii, right? So next, what else? The theorems, they fall. After you wrote this, focus on your isosceles theorems. So the first thing that said, if you have lines that are equal, two adjacent lines equal to each other, that means your base angles are equal. Which angles are base angle? So we have angle B is equal to C2. First deal with your isosceles. If you see this, remember isosceles triangle, then you will be fine. And then you move from there. So we said B is equal to C2. Why are we saying that? We say angles opposite equal sides. Another reason you can say base angle of isosceles triangle, but I don't love that one. I love angles opposite equal sides. So okay, that's fine. So you are done with your isosceles theorem. So what else next is your exterior angle. Then you are done if you can know to relate the proof to the theorem. So what else? In there we have the exterior angle. Which one is our exterior angle in this triangle? You see we have an exterior angle of O2. Angle O2 is equal to what? The exterior angle of a triangle is equal to the sum of the two opposite interior angles. Which are interior angle? This angle and that one and that one. So, but we want the opposite interior angle. So, C2 plus angle B right? So these are the opposite interior angles of O2. Now, which angle do we need? Remember, I said we want to relate angle O and angle C, the center circumference theorem. So, which angle is not part of O and C? B is outside there. So here we have to remove the B with a C2. Remember, you said B is equal to C2, so we can write that C2 here. In the place of this B, we can replace it and have C2. So what do you have? You have 2C2, right? So what is the angle AOB equals? So now you have O1 and O2. What is O1 plus O2 equals? O1 plus O2 is equal to the big angle. What is the big angle? That big angle is equal to AOB, right? AOB is equal to AOB, right? So in the place of O1 plus O2, we write AOB. So we have AOB, right? We said, sorry, mistake. What? And pardon me for that. I made a mistake. Okay. All right. So we said O1 plus O2 is equal to AOB. But what is the value of O1? O1 we said is equal to 2C1 plus. What is O2? O2 is equal to 2C2. Then you have equals to AOB. I'm running out of space, sorry, you'll forgive me. I'm sure you are still following. Then we have AOB is equal to 2C1 plus 2C2. Then you see what is the common factor here. The common factor is a 2, so we can factor out, and you have C1 plus C2. Then when you hear, you look, what is C1 plus C2? There you have C1 and C2. C1 plus C2 is equal to angle C, right? And angle C, you have 2C is what? ACB. In the place of that, right? 2ACB. So you have proven that AOB is equal to 2ACB. Quite easily done. But it's a long video because I wanted to take you through step by step, right? The important parts here is this one and that one, and of course this one, and lastly this one. Then the extraction part, you can do it for your own benefit. It does not have any marks. Then you make sure you write the reasons in every step. The reasons, like here we forgot the reasons. You write that this is exterior angle of triangle. Make sure in everything you write, give reasons. Then you have successfully proven that. Thank you very much for watching the video. In the next video, I will be discussing the next theorem to ensure that you understand. And if you have any questions, you are free and welcome, more than welcome to ask. I will be able to help you in the comment section below. Thank you very much. See you in the next video.